Welcome everyone. My name is Erik Veld and I'm a developer advocate here at HashiCorp. Today I'd like to talk to you about Nomad, and especially some of the less highlighted sides of Nomad. We often talk about containers and cross-cloud scheduling and fancy features such as autoscaling, but I feel one of the most powerful features of Nomad is often overlooked. And that is the flexibility of Nomad and its ability to run other workloads besides just containers. So today I will be showing you how you can run workloads that you might have been scheduling using other systems and tools such as systemd, scripts, or maybe a provisioner, and instead use Nomad to run them, using one common workflow and without having to containerize any of those workloads. And at the end, there will be some shiny new things for you as well to see, so be sure to stick around for that. All right, there's a lot to go through, so let's dive straight in.
Okay, so let's start off by creating a new file. So let's create a java.htcl file and initialize an empty job file. Now, for simplicity, let's name the job, the group, and the task all Java. And the important bit that we actually need to set is the driver, which in this case will also be Java. Now, in order for our application to run, we need to have some jar files. So we're going to pull those in through artifacts. So let's add those, right? Now, the important one here is the server.zip artifact. This will actually contain our jar files that we will be running. So let's take a look at those. So if we do a zip info of that file, so let's do files java server zip, we can see that it contains two jar files, right? So it has the server.jar, which is the actual Minecraft server. And then we have an additional jar file, which is the Fabric server launcher, which actually wraps that jar file and allows for mod support and things like that, right? Now, besides that, we're also going to be pulling in some mods and a world for us to play in. Okay, so Minecraft actually needs some additional files in order to be able to run. So we're going to define those through templates. So let's add those, right? The first one is the EULA. So we need to set the EULA to true so that we accept that. Let's format that a little bit. And we have the server properties, which is actually the configuration for the server. Now, the important bits for us is not that top bit, but the archon we want to enable and the whitelist, we want to disable that so we're able to join that without problems. All right, let's configure our servers. So we call that actual jar file that we mentioned before, the wrapper, and we set that as the jar path, and we can pass in some arbitrary arguments and we can configure the JVM, right? So in our case, we want to give it some more memory. Now we also need to set that memory on our task so we actually get allocated enough. So we're just gonna give it plenty of CPU and 4 gigs of mem. Okay. Now, there is a little caveat, right? Because that world zip contains files zipped by my user on Windows, we actually need to specify the user of our task. So in this case, I'm just going to set it to root so we don't run into any problems and it can access and create all the files it wants to. Normally, you'd want to be a bit more specific, but that's just for a workaround of that world.zip. Okay, now in order to reach our application, we want to add some ports. So in our case, we actually want to add 2 ports. So we have the server port, which we joined the game with, and the archon port, which we'll use for remote admin. And then for other services to be able to find our service, we want to add some Consul service stanza. So there we go. We have our server and we have a sidecar service for that. And then we actually do the same for the archon service port. Okay, with all that said, we should be done. Let's run this job. So let's do a nomad run of the job file we just created. Okay, so it says it's running. Let's actually inspect if it's all healthy. So let's do a status of the Java job. Okay, it says desired run and status running, so that should be fine. Let's also take a look at the allocation and make sure that's all good. So downloaded the artifacts and then says task started. So let's give it a try. But before we can do that, we need to set up an ingress gateway first, so I will be able to reach our service from my desktop. So let's start off by creating a file again, ingress HCL, Let's start with an empty job again, and let's call the job and the group ingress. Right? This time we're not gonna need the task at all. So first off, we want to set the type of the job to system, so it'll actually run on all the nodes on our cluster. Then we need to set the ports. So we're going to set the port for the Minecraft server, and we're going to bind it to a static port, and we're going to do the same for the Archon server. So then we need to add this service stanza. So in this case, we're going to add a connect gateway of the type ingress, and we need to add a listener for the Minecraft server and a listener for the Archon server. So with this set up, let's deploy this. Do a run. And we can see that Nomad deployed it on all of our nodes, right? We see 3 allocations. So we should now be able to join our server. Let's launch Minecraft. And let's go to multiplayer and then join our server. Okay, that seems to have worked. That's pretty cool. Now, since we're here anyway, why don't we just continue from here? Let's see. I think I left it. No, not that junk. Yep, there we go. Nomad server, and let's grab that Redis job. Let's see. I think this is a nice place for it. Let's configure the IP of my Nomad server. So that's 10.5.0.4, standard port. Save that. Cool. That's our Nomad cluster. We see our ingress jobs, our Java job that we're actually now inside of, which is kind of cool. Yeah, and the ingress deployed over all the nodes because it was a system job. Let's try running a Docker job, right? Let's submit this this Redis job. All right, pending. Fingers crossed, it'll actually work as well. Yeah, running. All right, let's double check that in the terminal. All right, so do a Nomad status. Yep, it's there. All right, Nomad status Redis. All right, running. Seems to be correct. What is the next job type that we should try to run? I think we should try something fun. Let's try a QEMU one, right? So let's create an empty job file called QEMU, set the job and the group and the task to QEMU again, and obviously the driver needs to be QEMU as well. Now, in order to use the QEMU driver, we need to pull in a disk image from the artifact stanza, right? So I'm gonna pull in a tiny core Linux just off of the internet. And then we're not gonna need any templates this time. We can immediately go to the config. So let's put that in. I'm gonna be using KVM to run the actual image. And here you can see me referencing that image. And then we're gonna bind VNC to localhost. And I'm gonna add a network device with some DNS. Now we're gonna need some resources, obviously, but this is basically all you would need for a QEMU VM. Now, because I wanna be able to reach it, I'm gonna add a sidecar task called VNC, and it's gonna run no VNC in a container, and it's gonna connect to that port that we set up in the config stanza, and then it'll be exposed on port 8080. So let's add that port here. And then we need to add a service so we can actually route through it from our ingress, right? So that's going to that port 80. And I'm gonna add an upstream to our Minecraft server, which will bind to 10.0.2.2 because of the internals of KVM. So let's run this job. Nomad run, the QEMU file. Okay, deploy that, wait for that to run. Let's take a look in game and see if it actually shows up. Oh, there we go. Yeah, it shows up. The QEMU job is running. All right. So in order to be able to reach it, we need to edit our ingress. So let's add an additional listener for that port 8080. All right. So that's going to the QEMU VNC service. And then we need to add the port as well. So let's add the static port going to 8080 as well. Okay, let's head on over to the browser. So VNC is running on port 8080. So let's open that and connect to the VM. Okay, cool. That's pretty tiny. So let's zoom that in a little bit. Okay, So let's run the Archon client against the local host. So in this case, it would be 10.0.2.2 because of KVM, the port we specified for Archon, and then the HashiCorp password. All right, seems to be connected. Let's do a little test message. Yeah, hello. Okay. Let's give myself some cake. I think I deserved it. Oh, yummy. Got it. All right. Let's put that down somewhere. Put it there. Nom, 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 nom. We connected a QEMU task to a Java task over Consul service mesh. I think that's pretty cool. So the next thing I want to do is use the exec driver, right? So let's create a file, start off with the empty job again, name everything exec, exec, exec. Now for the driver, I actually want to use the raw exec. And that's because I need access to the actual file system, and I'll explain a bit more about that in a second. Right, so we're gonna pull in our artifact. In this case, we're gonna be pulling in promptail, and I'm gonna be writing it to a local file called promptail as well. Now, promptail is gonna need some configuration. I'm going to be specifying that again through the template stanza. Now, I'm gonna point promptail at a loki that'll be running somewhere else in the cluster, but I'll be pointing at localhost because we're going to use Consul connect again to route to it. I'm going to keep track of the positions of the last logs. I'm going to read from localhost and specifically from the allocation path where all the logs of all the allocations are. That's why I need access to the actual file system. So let's add the actual config then. We're going to use the binary that we pulled in through the artifact stanza above, right? That's the promptail to local promptail. And we're going to pass it a configuration file that we defined through the template. Now we just need to add some resources, and it could probably run with a lot less than this. So we actually want this job to run on all of the clients in our cluster. Right, so we want to specify it as a system job. That's why we're changing the type, right? Then it actually listens on port 80. Not that we're going to use it in this case, but let's just specify it. And we are going to need to create some service stanza because we want to point this instance of promptail to that instance of Loki that will be running somewhere. So we're going to run a sidecar pointing at the service Loki, and we'll be able to reference that via localhost port 3100. Okay, let's run this job. So let's do a nomad run, demo exec HCL. Deployed, I see 3 allocations, so that looks good. And they all seem to be spread out over the 3 nodes we have. But what if you want to run something that doesn't have an official task driver? You're actually able to write your own task drivers. I wanted a way to schedule minecarts in Minecraft, so I built a task driver for it. And what I had to do is basically implement these few interfaces that manage the life cycle of a task. So starting a task, stopping a task, inspecting a task, right? And for me, that basically mapped to these functions, right? I wanted to summon an entity, which is a minecart. I needed to be able to remove that entity, and then I needed to be able to describe it or inspect it, right? And for me, it was as simple as sending these commands to the Minecraft server. Now, let's try this out by actually writing a job file for the task driver that I made and see if we can spawn some carts in-game. Now, I've already configured Nomad to use this task driver using the plugin stanza. Now I've configured it to talk to localhost on port 25575 using the password we used before. Okay, so now that the task driver is all set, let's create a new job file. Let's call it custom. Start off with empty again, even though we're not going to need most of it. Let's just name everything custom again. All right. And then let's get rid of everything we don't need. So we don't need the network, we don't need the artifacts, we don't even need the resources. We do need to set the driver though, and that's gonna match the one that we defined in the plugin before. So we need to set the config. So in our case, we wanna set which entity we're gonna spawn and the location of where we wanna spawn it. So that's gonna be X, Y, and Z coordinate. And that should be everything we have to do. let's do a Nomad run of our custom job. And if we look in game, boom, there's our minecart. Nice. Oh, I can see that sound becoming annoying really quickly. Let's get rid of that cart. All right. But let's actually watch that allocation, right? Because since Nomad is controlling it, it should actually manage the life cycle. So if we wait a few seconds, there we go. Nomad actually rescheduled it and our minecart is back. So whenever something happens to the minecart, Nomad will restart it. But thanks to Nomad, I now don't have to worry about Nick griefing me anymore and destroying all my minecarts.
Hey, Erik. Oh, hello. Wow, this is, seriously, I've just been chased across, like, I don't know what that plane is, but orcs, Erik, there's orcs. Wow, what have you done here? Never mind the orcs. No, what is this? This is, hey, can I play with this? Can I have a go? Come on, let me have a go. I've got an idea, Erik. Let me just edit your file here, okay? I'm gonna edit this now. If I change this entity to TNT Minecraft, I think this is gonna solve our orc problem for good. Let me just run this. So Nomad run cart.hcl and hey, look, so I think I made yeah. Okay, so yeah, later. Okay, bye.
Seriously, every time. Oh, I'm so done with this. I think I'll just go find a job at the zoo. Now, at the start of this presentation, I told you to stay tuned for something new. Sometimes you want to run applications, but you don't want to write the job files yourself. You just want to take an existing package and then customize that through variables and run that on your cluster. And this is exactly what Nomad Pack allows you to do. So let's take a look at the CLI, right? If we run it, we can see some of the commands. We can actually take a look at some of the packs that I might have in the registry. So if I run Nomad Pack registry list, I will see the packages that are currently available. And right now it contains actually 2 packages that I want to run. So I want to run Loki, and then I want to send that Loki data to Grafana. So instead of writing those myself, let's just use the packs. So I can just run Nomad Pack, run Loki, and Nomad Pack will actually run it for me. Now it said it was deployed, so let's take a look at the actual status. So we can do Nomad Pack status. It says it's running. Let's just confirm with Nomad itself. So Nomad status Loki seems to be running. Let's move on to the Grafana job then. Now, the Grafana job is slightly different because I actually want to customize it. I want to set the upstream for Grafana so that I can actually reach Loki from my Grafana pack. So we want to populate that. So we first need to create a variables file. So let's create a file called grafana.hcl and let's add the upstreams variable. So in this case, the upstreams variable is an array that contains objects of upstreams and that have a name and a port, right? So in this case, I want to connect to Loki on port 3100. All right, so now that we have that variables file, let's run that pack and pass in that var file. So we just specify the var file field and then run that. So let's double check that everything is running correctly. All right, so let's go over to the browser and take a look at the Grafana UI. Let's add that Loki data source, which should now be reachable on localhost 3100. So if we add that data source and then save it. All right, it found it. So the connection seems to work. Let's see, let's take a look at the logs. So let's go to the log browser and then well, I see files, allocations, so that looks good. We see all the different jobs that we've been running. Let's take a look at the Java job. So let's see if we got any logs out of that. Show logs. Yeah, there we go. We see the Archon connections that the task drivers are making. I wish we could see Nick's minecart that blew up the server, but I don't think that'll be in here. But yeah, we now have Grafana and Loki running without having to write a job file at all. We are working on adding new packs, and we hope that you all will be adding your packs as well and report any issues that you might run into. Now, let's take a look at one of these packs, right? Let's grab the Loki one. So it consists of a variables file. So these are the input variables that you can use to configure a pack. Then we have an output file, which you can put any message or maybe links to things. And then there is the important metadata file. So this specifies the name of your pack and the version. And then the most important part is the actual templates. So there are some helper templates. In this case, we have a helper for the job name in case you don't pass it in, and one for the region. The important part is this Loki.nomad template. So this is basically a job file that includes some templated variables. And it's mostly replacing these strings with the actual things that get input by the user.
So let's reflect and look back a bit at what we've done, right? We've scheduled a Java job, which was the Minecraft server. We just pulled down the jar from the internet, from the official download page, and ran it directly. Nomad took care of all the isolation and the network plumbing for us, right? Then we created an ingress gateway to allow us to connect to that server. And we only had to basically write some network stanza and a service stanza. We didn't even have to implement a whole job. Of course, we also ran a container just for good measure. We ran a virtual machine using the QEMU driver, which we then connected over Consul service mesh to that Java job that we created before, the Minecraft server, and we actually executed commands against it, right? Those are two totally different task drivers working together, and they don't even know that the other one is different. We then use the exec driver to schedule a plain Golang binary across our entire cluster using a system job. And we even used a self-built task driver that we built for Nomad, which scheduled workloads that Nomad normally doesn't support, right? In our case, we scheduled minecarts inside of Minecraft, right? If you can do that, then what is the limit? And finally, we used Nomad Pack to schedule commonly used applications such as Grafana, Loki. You can imagine this for databases and things like that as well, without even having to write a job file at all, right? That's pretty amazing. Now, to round off this presentation, I'd like to quote something someone said a really long time ago, which was this, right? My Elvish is a bit rusty, but luckily some chap called Tolkien translated it in the 30s. And he translated it roughly as this: one ring to rule them all, one ring to find them, one ring to bring them all, and in the darkness bind them. Now, I don't think he was that far off, but I think his Elvish was a bit rusty as well, because I think what that Sauron fella really meant was this: Nomad to run them all, Consul to connect them, Vault to secure them all, and with the secrets bind them. By using Nomad, you can use one common workflow across a different variety of workload types. And if you just want to run containers, it's fine, Nomad can do that. Even if you're already running another scheduler to run your containers, Nomad can be a real nice complement to any of that for the non-containerized workloads you might have. And by combining it with Consul, you get network security, routing, and observability that extends across all of those clusters, right? Making it possible to do things like simply and securely routing traffic from a Kubernetes pod all the way to your Nomad workloads, which might be running in your data center in a QEMU VM. And by combining it with Veld, you can have one common secure approach to providing any type of secrets, maybe API, X509 certificates, or maybe dynamically generated secrets, right? And you can distribute them to any of your workloads. So the next time you need to run an application, whether it's containerized or not, consider Nomad. It's a great way to simplify your operational infrastructure. So with that, I'd like to thank you and have a great day.